In this lesson, I will be defining the different sets of numbers that we have. The objective is for you to be able to classify numbers in each set of numbers that we have. So let's begin. First of all numbers that you have ever seen in your life are called real numbers. When you get to high school, we will introduce non-real, also called imaginary or complex numbers. But for now, in middle school math, we only concentrate on the real number system. We have subsets in the real number system. So let's begin with a diagram. So what I have drawn is a very large rectangle where a line is drawn through it, and this rectangle, the entire large rectangle, represents all real numbers. So again, that's every number that you've ever heard in your life. Now, the reason I have a line drawn inside the box is because we have two categories of real numbers. One are called rational numbers, and the other are called irrational numbers. So I have placed rational numbers on the left-hand side and irrational numbers on the right-hand side. Notice that both types of numbers are under the category of real numbers. So let's first talk about the irrational numbers. Irrational numbers are numbers that never repeat digits in a pattern, and the numbers never end in a decimal. So we call those non-repeating, non-terminating decimals. So let's write down a few examples of irrational numbers. The most popularly known irrational number is the number pi. Pi never repeats any of its digits in any kind of a pattern, and the number goes on to infinity. So it is a non-repeating, non-terminating decimal. We also have other ones that you're not as familiar with, but we will get familiar with them. Another example is the square root of 7. We could also see irrational numbers written as decimals. So if it doesn't repeat and it doesn't end, I have an example of 0.386572, and then it continues on forever, so the way I show that is with the 3 dots. So those digits don't repeat in any kind of a pattern, and they go on forever, shown by the 3 dots. That is an example of an irrational number. I also want to point out that this number, 0.383338 ... is also an irrational number. There is a pattern to it, however, the digits don't repeat in a pattern. For example, you cannot put a bar over the 3 and the 8 because you keep adding another 3 in there. So that is another example of an irrational number. Now let's move over to rational numbers and define that. A rational number is any number that can be written as a fraction, and in decimal form, they are decimals that terminate, which means stop, or decimals that repeat. So again, a rational number is any number that can be written as a fraction a over b. A and b have to be integers, and I will define what an integer is in a moment. And b does not equal 0. So in decimal form, they are either terminating, which means numbers that stop, or repeating decimals, which means you can use the repetend to show that it repeats. So some examples of rational numbers, and I will put a few down here. Examples would be the number 3, the number 1/2, -5 3/8, and the square root of 81. These are a few examples of numbers that can be written as fractions. 3 can be written as 3 over 1. 1/2 automatically is a fraction, and so is -5 3/8. And the square root of 81 is equivalent to 9, and 9 can be written as 9 over 1. So that's why all of those fit into that definition of rational numbers. Now, inside of rational numbers, we have a lot of different other kind of numbers. So the first one is called integers. The definition of integers is whole numbers and their opposites. So in my own words, I say that they don't have any parts when they are simplified. Parts meaning fractions or decimals. So if you take a look at the examples of rational numbers, we had 3, 1/2, -5 3/8, and the square root of 81 as just some examples. 3 is also considered an integer because it is a whole number. It doesn't have any parts. However, 1/2 is not an integer because it's a fraction, which means it's a part of a whole. So no 1/2 as an example for an integer. The same with -5 3/8. The 3/8 is a part of a whole, so it is not an integer. However, the square root of 81 is an example of an integer because, like I said before, it simplifies to 9, and 9 is a whole number. So let's talk about that other part where it says, and their opposites. So the opposite of 9 is -9. So -9 would be an integer. In fact, the integers are made up of all numbers in the negatives and in the positives. So I have those 3 dots that mean it continues on forever. So when the 3 dots start off, that means it continues on in the negative, and the 3 dots to the right means it continues on in the positive. So all the numbers that you could list out in that bottom list there would be considered integers. They don't have any parts, but they can be positive or negative or 0. The next set of numbers is inside the integers, and those are called whole numbers. Whole numbers start at 0 and go up forever, but they don't have any what I consider parts. So again, no fractions or decimals in its simplified form. So if you take a look at the examples of integers, we had 3. 3 is also a whole number, so we're going to put that down here with the examples. The square root of 81 is 9. 9 is a whole number, so I could put the square root of 81 here. But -9 is not a whole number because whole numbers can't be negative. So we cannot include -9. So it starts at 0 and goes up. So we can consider all of these integers starting at 0 and going up to be whole numbers as well. So another form that I want you to be aware of is it could be a fraction that simplifies. So let's move that back up there. So 15 over 3 is a fraction that simplifies to be 5. So that is also a whole number. So keep in mind that you should always simplify the numbers before you decide what kind of number or what set of numbers that number belongs to. Keep in mind, whole numbers cannot be negative. Let's move on to the last set of numbers that we have, and these are called natural numbers. They're also called counting numbers. Natural or counting numbers are numbers that start at 1 and go up, but they don't have any parts either. So if you notice the difference between whole numbers and natural numbers, the only number that is a whole number that is not a natural number is the number 0. So all other whole numbers other than 0 are called natural numbers. And we call them natural numbers because it's what we naturally start counting with as babies. The very first number that babies learn is the number 1. So when you learn to count, you start with 1 and then 2, 3, 4, etc. Those are the natural numbers. So examples, they start at 1 and then go up. So the important thing to remember is that natural numbers do not include 0 and they do not include negative numbers. So what you will be required to do is when given a number, you have to tell me what set or sets of number that number belongs to. It will be to your best interest to make sure that these notes are near you until you get these definitions down without needing notes to classify numbers.